As we alluded to in the previous video, one of the reactants in a particular reaction will run out first. And how does that influence the products? So the next topic we're going to consider is something called limiting reactants. So we can say that the reaction for commercial hydrogen cyanide is 2CH4 plus 3O2 plus 2NH3 giving 2HCN plus 6H2O. If 1.0 kilograms of each reactant is available, how much HCN could be produced? So the first thing that we're going to have to do is determine what's called the limiting reactant. And that is what's going to run out first. So we have 1 kilogram of CH4, we have 1 kilogram of O2, and we have 1 kilogram of NH3. When we react those together, we're trying to figure out how much HCN is produced. So why don't we take 1 kilogram or 1,000 grams and use stoichiometry and dimensional analysis to figure out how many moles of HCN could be produced from 1,000 grams of each reactant. So if we have 1,000 grams of CH4, from the periodic table, we know that 1 mole of CH4 is going to be equal to 16.0 grams of CH4. Then from the balanced chemical equation, for every 2 moles of CH4 that reacts, we have 2 moles of HCN that are produced. This is going to give us a total of 62.5 moles of HCN. Now we do the same calculation for 1,000 grams of O2. From the periodic table, 1 mole of O2 is 32.0 grams. From the balanced chemical equation, we need 3 moles of O2 to produce 2 moles of HCN. This is going to give us a total of 20.8 moles of HCN. Lastly, we take 1,000 grams of NH3, and for every 1 mole of NH3, that's going to equal 17.0 grams. From the balanced chemical equation, for every 2 moles of NH3, we have 2 moles of HCN. This gives us a total of 58.8 moles of HCN. So now we can look at these and see the amount that was produced if 1,000 grams of each of our reactants reacted completely. So the smallest number of moles produced is going to be produced by consuming all of the O2, or the oxygen gas, because 20.8 moles of HCN is the smallest amount here listed. So the thing that's going to determine, or the species that's going to determine how much HCN is produced, is going to be the oxygen. Okay, so we call that, we can say therefore O2 is the limiting reactant, because that's going to dictate how much HCN can be produced. So we've already calculated the moles of HCN produced from 1,000 grams of oxygen. So now we just need to convert this over to grams, because 20.8 moles of HCN will be produced. From the periodic table, 1 mole of HCN is going to be 27.0 grams. When we do that conversion, we get 5.6 times 10 to the second grams of HCN. And this is the amount of HCN that's going to be produced when we react 1,000 grams of CH4, 1,000 grams of O2, and 1,000 grams of NH3. To kind of recap, you calculate how many moles of HCN would be produced if all three of these reactants totally reacted, then investigate which one would be the smallest amount of HCN in terms of moles. In this case, the oxygen produces the smallest amount. We call that the limiting reactant. And then from there, once we determine the amount of moles of HCN produced from the limiting reactant, we can use stoichiometry to calculate the mass of HCN that will be produced.